Assalamu alaikum everyone. Today my presentation topic is Introduction to Partial Differentiation. Now I am going to share my slide. It is presented by me, myself Mohammad Taha. My ID is 1405. Now I am going to share about the agenda of my presentation. Definition of partial differentiation, notation and terminology, basic concept, partial derivatives, interpretation and geometric insight, higher order partial derivatives, practical application, and conclusion. Now, I am going to share about the definition of partial differentiation. Partial differentiation deals with the rate at which a function changes with respect to one of its variable while keeping the other variable constant. It extends the concept of differentiation to function with multiple variables. Notation and terminology. The partial derivatives of a function f with respect to a variable x denoted as partial of f. The symbol of partial is used to represent partial differentiation. For example, partial of x, partial of dx, dy of f, etc. I am going to share about the basic concept. Function of several variables f of x, y, z. Partial derivatives are computed by treating one variable as the independent variable and keeping other constant. For example, if f of xy is equal to 3x whole squared plus 2xy plus y squared, then ddx of f equals 6x plus 2y. If we look at the law of differentiation ddx of x to the power n, and from this we can easily say that n x to the power n minus 1, so that in here 2 comes in first, and so that it happens in 6x plus 2y, and dy of f also follow the first rule. Partial derivatives. The partial derivative of a function with respect to one variable is computed similarly to ordinary derivatives, and the example is in the previous section, and that's example are same to see. Now, I'm going to share about the interpretation and geometric insight. Geometrically, the partial derivatives represent the slope of the tangent line to the curve formed by the intersection of the surface with the plane. The measures the rate of changes in one direction while holding other variable constant. Now, I am going to share about the high order partial derivatives. Just as single variable calculus, we can take higher order derivatives in partial differentiation. Second order partial derivatives are denoted as dx square of f, d square dy square of f, and the mixed second order derivatives like as d square dxy of f. Now, I am going to share about the practical application. In physics, partial differentiation is used in modeling physical systems with multiple variables such as motion in 3 dimensions. Economics, marginal analysis involves partial differentiation to study how one variable changes with respect to another in economic modules. In engineering, in fields like as fluid dynamics, partial differentiation helps describe changes in variables like pressure, temperature, and velocity. Conclude my presentation. The partial differentiation is a powerful tool in multivariable calculus. It enables us to analyze and understand how a function changes concerning individual variables. Its applications are widespread in various scientific and engineering disciplines. Thank you, all the best. Assalamu alaikum everyone. That's all about my presentation. Assalamu alaikum.